So, welcome everyone. So, today's session, which we have, is on the LangGraph. Like LangGraph is so AI agents are something which are going around everywhere. Everywhere you will be seeing and hearing about the AI agents, and within that, one of a good frameworks and libraries which is there is a LangGraph that gives a very good control over how we build AI agents. So today we have Malvika here with us who will be presenting on building AI agents with LangGraph. So Malvika, to you now.
Yeah. Thanks, Rishi. Hi, everyone. Uh, so I'll just share my screen and I'll start with a quick introduction of myself as well. Is my screen visible?
Yes,
Yeah, okay, thanks. Uh, so my name is Malvika and I have 14 plus years of experience. Uh, in the field of AI NLP, I have relevant experience of say more than 4 5 years. And currently I'm working in an MNC as a product lead. And it's today's session is going to be a very, very interesting session because it's something what we are talking about nowadays. It's agentic AI everywhere, which is to be heard. And today we learn something practically in this session, how to create one of the agentic AI workflows hands-on using LangGraph. So we have in the market a lot of tools like we have AutoGen, we've got N8N. These all are frameworks with which we can create workflows. But why LangGraph? LangGraph is something which gives you a lot of transparency or a lot of flexibility in how to create the workflow. You can tweak your calls to the LLMs. You can tweak your decision making when you are creating the workflow. So this is actually a very, very interesting framework. So what we are going to do today is we'll start with uh, LLM. We'll start with creating a AI agent. And what this agent is going to do is it's going to perform some kind of summarization. So we'll give it a paragraph or a bulk of text. It will do a summarization and then we'll try to use the same summarized text for doing sentiment analysis, whether it's a positive or a negative sentiment. And if we have time, we'll take it ahead for doing a web search, that is how can we further ahead link this summarized text which has got some kind of sentiment, and we do a web search based on the sentiment and enhance the results basically. So this is what we are going to do. We are going to start with agent input. We'll do the summarization of text. We have sentiments. uh, so we are going to use this entire framework. Workflow is going to be done with the help of LangGraph. And if we want to connect externally to some kind of tool to do a search or something, we can use an API from Travely. And based on that, we can get the results as the output for the entire workflow. So I hope it sounds interesting. So what are the key outcomes of today's session? First is we are going to understand the basic concept of building the API. Then we are going to configure the API keys, because when we are trying to use any LLM for doing the decision making, the brain of this entire workflow, we will be using an LLM. So for that, we will have to configure API keys. Then we will understand how this entire workflow works, how is it created, That is, what are the various components of LangGraph? That is, what is the state, edge, nodes, and the other components of it. And we'll define custom tools so that we can leverage as part of the workflow that we are going to create. So the very first question what comes is why LangGraph and what is it basically? So we all keep hearing about it every day that a lot of autonomous systems are coming up. It's AI is changing the scenario, the work scenario at a very rapid pace. So these AI agents, they are the autonomous systems that operate independently. So what happens is we need something which is going to augment this LLM. So basically, if we give an input to LLM is basically the brain, which is going to do the processing, augment your whatever queries you have, and it gives you the result. So when this LLM is doing the process, it might be retrieving some information which is already maybe stored internally as a any kind of a flat file or a database or any kind of a system file. Then the LLM has got memory, and after that, if the domain needs or the workflow needs, it will be referring or using certain tools also to do the decision making, basically. So basically, we give an input. The LLM is going to use either retrievals, memory, and tools to create a contextual output. So it's a LangGraph is basically a very powerful framework. So this allows the developers to create stateful. So when we say the word stateful, stateful is something which is when we go, like say for example, here we are here, start. When we go this agent, this action, they all are called nodes or steps. So when we go from one step to another step, what was there in the previous step is retained, is remembered. So that is why this land graph works in a very powerful, stateful system basically. And one very good thing about it is it's an open source and it's free to use, and it makes it easier to define the workflows or to manage the transitions from one node to another node very easily. So when we are saying the word node, what exactly it is? So this node is anything. It's like a function. If there are some people here who come from a coding background, we know that function is something, a group of code or anything which executes or performs some kind of an action. So this node is exactly this is it includes a function which it executes, and it's not necessary it has to be a single node. We can have this node A is doing some function and the result is going to be passed to node B. So there's always a connection then between node A and node B, which we call as an edge. So these edges actually determine the flow. How is this information going to flow? Like right in this case, we can easily see that the information is going from node A to node B. But there might be cases when we need to make a decision. From node A, based on a condition, the information will go either to node B or node C. So that is called conditional edge, and even that is very much possible in LangGraph. And the thing is that it doesn't go for linear decision making. Here we can have conditional decision making. It's on us when we code it or when we create the workflow, that how do we tweak the workflow and how do we want the information to be flowing. So this entire thing, this node A is getting some input, it's being passed to node B. So this entire thing, input, variables, what it is carrying, or the outputs, the entire thing together is known as a graph state. So the graph state is something which you can think as a container, which contains your inputs, variables, and outputs, and you can take this container and it can be accessible anywhere. So basically, it's a low-level uh, land graphs, low-level primitives. They provide the flexibility, what I said just now, to create fully customizable agents with very easy control flows. Like what we discussed right now here, we can have a single, we can have conditional, we can have hierarchical, any kind of a workflow can be created, and we can prevent the agents from veering. We can have a human also in the loop so that the agents don't veer off, or we can control the quality of how information is flowing between the agents. And the land graph's built-in memory, one very good thing is it stores the conversation histories, so the context is maintained, and we get the contextual outputs. What we get is very rich across the sessions. So if we've heard about LangChain, and today we are talking about LangGraph, so and we want to compare architecturally what's the difference between LangChain and LangGraph. The first very the difference which stands out is LangChain is it's sequential. It goes as a series, we can say, but LangGraph is completely graph based, and anything which is graph based is very very optimized. It's more versatile. We can make a lot of decision making is very easy because of the graph structure. When we talk about control flow in LangChain, we use Python functions like decision making with if, else. We can make loops, use loops. But in LangGraph, we make with the help of nodes, graphs, graph edges, and we have conditions. Why do we need to use LangGraph? So this LangGraph is used when we have multi-agent workflows, when we have iterative systems where we need to jump around for the decision making. It's not flowing linearly. Maybe from node A, we have to jump to node B. In that case, it's going to be always an option of LangGraph. When we talk about state management, now what exactly is a state? What is the meaning of a state? We'll be seeing this in code as well because LangGraph works completely on state. State, to build a very easy understanding is it's like we can take it as a container which contains all the relevant information when during the execution of LangGraph workflow. So every node in the graph can read and write uh, to this state, and this state is shared across the different nodes to make it very easy to understand. So this is stateful, whereas LangChain is not doesn't work in this particular pattern. So LangChain is basically stateless. Because LangGraph works on a graph architecture, so it's little complex because of the nodes and the edges. So we need to understand how do we connect the nodes and which are the relevant edges which will be giving us the outputs. So to summarize, I think when we talk about chatbots or a simple QA system, LangChain is good enough. We can use a RAG model. But if it's something which is a lot of agents are working together, it's a collaborative kind of a like decision making is being done, then LangGraph is the right choice, I would say. So what we will be learning today is we'll just go through this and then I'll pull up this the takeaways what we cover up in today's session. So, so Rishi, can we start with the practicals, the hands-on?
Yeah, yes, Malvika, we can start.
So is my screen visible or I'll just complete screen share?
Yeah, not visible yet.
Okay, I'll just share it.
Yes, now we can see the code editor.
Okay. So to begin with, when we discussed about just now, I spoke about nodes, I spoke about edges, and I spoke about information flowing from one node to another. And the entire thing was done in a workflow framework which is called LangGraph. So we need to install certain libraries so that we can get started in using this uh, these codes, which you can see out here. So Rishi, can you just brief them how they're going to do it or they're aware of it?
Sure, sure. There's like one thing you will see in your right hand side a start kernel. So you can also code together if you want to code together with Malvika. So one thing is like the way Malvika did just now, you can start the kernel so that you will be able to execute the code in the right hand side. And one more thing, like if you want to get the copy of the code, you can click on the mentor's code at the top side. Like you have a call button, just beside that you have a mentor's code button. So if you click on a mentor's code, you will be able to get a read-only version of the code, which you can copy paste and run with your once the kernel starts. Okay, I think sure, Malvika. With that, let's get started.
Okay. So here, initially we have to install all the libraries and we just run this code. So all the related libraries they'll get installed. Very important is LangGraph works, most of the commands in LangGraph works with updated version of LangGraph. So it's always better to use the latest version of LangGraph when you're working on this particular workflow. And then you need to create Open AI API key. Um, if you have your own API key, you can use that, or else this is the API key you can use. This is just for a temp period. It will be deleted after the session. So now here, this is the agent. This is the state what we are creating. This is very important. Now, what is the state? This state is actually going to be the container which will have inside this the information and which we will be using across the different nodes. So here, when we talk about it, it's like a shared state. So the shared state is something like this shared state is something like a dictionary where we'll have a key value pair. So this, when we say this as typed dit, this means it's basically a data structure which is going to be like the data type of this is going to be a dictionary type. So here it's going to consist of, these are the variables what I have created. We'll have input text. The data type is going to be string type. We have summary. We have sentiment classification. For the time being, even if you don't copy search suggestion, it's okay because uh, the first thing task what we are going to do is we are going to take a bulk of text and we are going to create a summary out of it. After this, we wrote a function here because we are going to create nodes. And when I was explaining, I said every node is like executing a function, basically a group of steps, what it is going to do. So here we created one function which we've called the summarize step, and this is going to be a part of the this state what we had created. So state is an object of this particular class agent state, and the output of this is going to go to another state. So here we are using an LLM model. This is the based on the OpenAI key. We will be using this model, and what we are going to do is we are going to create a prompt which is going to summarize the text in a single line, and the input is going to be what we have already defined here. So we are going to call this here, and the return type is going to be the input text is going to go to the node, and we will be whatever the result is, that is going to be the return type of this particular node. After this, we have a connected node. We're creating another node. We've not connected as yet. We're just creating another node, which is going to basically classify the the previous node, what we had got here, the output of this, which is called summary. We want to find the sentiment based on that. So now we have two nodes. One, the first node is going to take the input text, which is going to summarize, and the second node is going to do the sentiment analysis based on that node. After the two nodes are created, the first we need to define the nodes. So we say we create a graph. Now, if you can recall, when I was sharing the slide, I had mentioned that your input, your variables, and your output are all inside one container kind of an object, which is known as a state graph. So here, this LangGraph is going to import state graph, and which is going to contain all your nodes, and there will be a state to it. Like when you start the graph, you have a start point, then you have the different nodes, and then there's going to be an end, which is the end of that graph. So here we add all the nodes what we've created. So we add the summarize step, which we have created here. We take this node, then we take the sentiment node, we added it up here, and after that we need to mention which is going to be your start of the graph. So here we've set the entry point as this summarize, which is a label for this particular node, and then we create an edge because information will be flowing from summarize to sentiments. So here we create an edge which is summarize to sentiments, and then we compile the graph. So here you can see how LangGraph has created a very nice visual of the entire node structure, the different edges and the nodes, what you have mentioned here. It's created a complete flow out here. Rushik, should I give time to do or should I continue?
Yeah, if there are any questions, guys, please be open to ask. Like if you want to ask anything, or if you want any time to stop, we can. But yeah, like 2 to 3 minutes, we can wait if others want to digest, and then we can continue. Yeah.
Yes, sir.
Okay. Great.
think I need to restart the kernel. Are the nodes running for all of you? Do I need to restart the kernel, Rishi, once?
Now, are you facing an issue with this?
Yeah, its agent state is already compiled, but uh, when I try to get it here, it's
Done, right?
yeah, now it's done. It's done here. Yeah, now
Yeah,
it's
now I think
done.
it is compiled.
Yeah. So this is a sample text, what I have put, what I want to be summarized.
Yeah. What is the error here?
It's the initial state, so I think again I need to,
Yeah, what's the last line? Yeah, to the very last. Okay, so the API key option must be set. So I think we're directly setting the key, right?
yeah,
So we have to use this given key names. Either we have to use this given key names or like, can you show me like where for the OpenAI you are setting the keys?
here,
Uh, but yeah, directly setting this will not work. We have to put it as part of a LangGraph LLM object. So where have we defined the LLM object?
here.
Yeah. So in this chat OpenAI, what you can do is bring this out in one more cell and try to run dot hello LLM object. You can bring it out and you can do dot hello LLM dot invoke just above this. Keep it. You don't have to cut. Just outside we will validate.
Hmm.
Yeah, here you can do LLM dot invoke. And this will give you like all the different keys which we need to set.
Or you can even set the environment variable using os.env.
No, because now setting the environment will require restart the whole thing again.
Mm.
Yeah, you can put hello. some text. Yeah, so once you run this, you will get the list of keys or environment variable which we need to set. So run it. Yeah, so if you come down now in the list of errors, yeah, to the last. Okay, so see, open API equal API underscore key. Okay, so either you have to set API equal to key in the above object itself. So you can put model equal to this, comma, API key equal to. So chat OpenAI object.
Yeah.
Within that, yeah, at the last you can put API underscore key equal to.
So my API, that variable name is
Yes,
this. So I'll
you can
put the
put the
entire.
variable name here.
Okay. This will do, right?
Put API underscore key equal to. Small.
So we need,
So is the LLM invoke working now?
Malvika, run that cell once.
So below.
Yes. And now run that LLM invoke.
Yes.
yeah.
I think now you can keep this LLM equal to inside the summarize step. Yes, and now compile this and continue.
I'll do the same thing here as well. So here we can see then the summary of that entire, I think we had around about 10 to 15 lines of text, and it has created this summary, and the sentiment of this particular text, the summarized text, is given as positive. So if you go through it, you will see that it's actually appreciating this particular city. That is why it's taken as a positive sentiment. So if we try to correlate this with this flow, so here we started the graph, the workflow. We summarized the input text out here, and whatever was the result of that, it was carried forward to this particular node sentiments for doing the sentiment analysis. And in the end, here we retrieved the output. So basically, summary and the sentiment, both we could retrieve it in this particular graph state. So this is one of the use cases, which is, I think it's a very powerful thing to 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 connect the different nodes and to analyze or summarize something in this way. The next thing, what is possible, what we had discussed earlier, is doing a decision making, that is, what kind of, from which node, based on a condition, where can the information flow. So that is another part of it. So we can use, there are a lot of tools, like Trevelly is one of the tools which is used for doing searches, web searches and all. So if you have a Trevelly API, you can use that, and we can create something with the help of Trevelly to further enhance this particular workflow. Rishi, should I go ahead with Trevelly? Do you have time?
Yeah, we can. Yes.
Okay. Okay, great. So they will be creating
Just a
Trevelly.
question. Just a question. Like, anybody has any questions on what we're going through? Like, you can unmute and speak if you want. If you have any questions. Yeah. If not, we will continue with the Teveli tool. Yeah. Sudarshan, you want to ask something? Can't hear you, Sudarshan. If you're saying something, or you can also put it in chat. If not, you can put it in chat. We will answer. Okay, Alvik, I think you can continue.
Yeah,
You can just put this down, Malvik, as a share screen part, right? You can click on that below arrow to.
yeah. So now what we are going to do is, like, if we get a positive sentiment, we are going to make a decision. So this node is going to be something like, we decide if it's a positive sentiment, it's if you had a chance to go through that paragraph for which we did a summarization and sentiment analysis, it was basically based on positive sentiments based off for a place called Paris. So now, if it's a positive sentiment, then we want to actually go for a search, a website search, where we want to extract the top three places for which we can visit in Paris. So then, and in case it's not positive, then we are not going to go for a search. So basically, this particular node, after sentiment analysis, is going to do a decision making. This is what we are going to create here. So when we do the decision making based on the sentiments what we have got, it's going to create an output node based on whatever results, whether it's positive or negative. So this is another output node what we are creating. And from the output node, we'll be ending the graph. So here we further extended the graph what we had created initially, where we just had summarize and sentiments. Now there's one additional node what we've put, two nodes we've put. One is for search and the other one is for the output. To take ahead the sentiments what we had got earlier. So if we see here now, based on the sentiments, we are now creating we are making a decision here, so which is conditional edge. Now, till here, this was a linear edge. It was straight. It wasn't making any decision. Here, we are creating a decision here. So if here, in your sentiment, we get a positive, then only it goes for a search and then it gives you an output. Negative sentiment, then it's just not doing any search, it's coming directly to the output. So we can just understand it from here, how the flow is running. We'll just compile the graph. To carry ahead the flow, what we were doing before, I'll use the same text, what we had used for doing the sentiment analysis. So now here we've got input text. We are going to do the summarization of it. We'll get an output of sentiment classification, what we did earlier, and then it's going to do a search suggestion. So after we build in the state, we will compile the graph. So now when we execute this state, it should be based on the sentiment. It should be giving us a web search. Okay, so I think I had commented the Trebly tool somewhere on top. Yeah, so I'll run it again because this was commented. Trebly search results.
Yeah, it is still running red. So yeah, now you think you can run again. Oh, it got stopped. You have to start again.
So I'll need to run it from the top cell again.
Yes, yes.
Okay. Do I need to run all the cells or I can just... Okay.
Yeah, did you set the key
Yeah,
to
I
the
said the, yeah, I said the key.
Yeah, I think it is not able to pick the environment now. What you can do is you can directly, as a variable itself, you can pass it. And you give that variable name. If you go to the error, at the bottom of the error,
Yeah, it's here.
yeah. So if you go to the bottom of this, bottom last part, yeah. So in this like this Travely underscore API underscore scheme small,
Hmm.
you can just pass it
Yeah.
as argument and then pass that as a key.
So I can just rename it here. I can just put here, right? The same.
No, no, we have to pass it as a key. Otherwise, like we have to restart the kernel again for that to take effect.
Okay. So I can just
Yes.
pass this entire thing.
Right, but key equal to the lowercase thing that you copied just now. You can paste
Okay.
it equal to the above one. Yes, equal to the above one.
Okay.
Yes. Hmm.
And I can skip all this or I have to run all of this again.
No, all of this is required, right? Ahead, summary
Yeah,
step.
they are
All this are
required.
yes,
Yeah.
we have to run it.
So we can see here because the sentiment was positive, so it has suggested for a website where you can go and you get the places what you can visit in Paris, basically, which was put as a query out here because we wanted to find out if it was a positive sentiment, then we wanted the top three places to visit in Paris, basically. So here we created a graph which started in a sequence first, which was one edge between the summarization and the sentiment. And after that, from sentiment, we did a conditional edge where it made a decision whether the sentiment was positive or it wasn't. If it was positive, it further went ahead to the web search node and it gave the output. Otherwise, it just came directly to the output if it wasn't a positive sentiment, basically. So this is it shows the way the entire workflow has been created is something. Now, if I want uh, another kind of a link to be done that you can take it ahead. You want some other kind of decision making, you can go on and keep extending the nodes. If I want a particular node is not needed in this second step, I need it in, after the third or the fourth step, I can create the logic or the flow in that way. I can move the nodes around and change the logic basically of the flow. So this is how powerful LangGraph is as a framework for creating workflows. Any
That's great,
questions?
Malvika.
Yeah.
Yeah, great work. I think this is good. Guys, like any questions on this? You guys want to ask anything? Rihan, you wanted to ask something?
So I was asking that what is the real life application of the Tavily tool?
Malvika?
Yeah, so it's basically it is used for doing search. Like say for example, you are creating an agentic AI app where you want now we can take it ahead. So now it gave you destinations, what you can visit in Paris. Now you want to understand which are the hotels where you can stay when you visit that place. So Travelly is one of the tools which can give you references or the websites URLs and the information related basically to travel, to hotels, and tourism purpose, basically. So that's traveling.
Okay, ma'am, thank you.
Thanks.
Great. Any other questions? Great, guys. I think I hope this session was useful to you all to understand like how AI agents can be used to build simple applications. In this case, like we build a simple few nodes agent with LLM, how we can expose the tools, and like tools allow us to access external world from the LLM. LLMs are trained only to access based on the trainings which they have been done with. But with tools, we can also give external access like a Tavily, which is similar to Google search. Your agent will have access to the Google like environment, and it can fetch real world data and then also make a decision on top of it. So all those things with agents, we can build some powerful agents. So that's it for the today. I hope you liked it and you will be attending it. We'll be coming up with multiple sessions over the future. Again, next week we have a session on RAG, which will be also done by Tushar Gaude. He's the director of Morningstar Software Engineering Director. So you guys can also join that session, which will be add on to what we did today. We will also talk about RAG, retrieval augmented generation. So great, Malvika. Thanks a lot. This was a great session. Uh,
Thank you.
So the Sudarshan has a question like, can LangGraph, the final compiled graph, be run asynchronously? Yes, Sudarshan, we can run the graphs asynchronously. There are like the LangGraph directly provides us an option of async run, whereas like we did invoke, we can also do a invoke, which allows us to run asynchronously. But when we run it in a Jupyter-like environment, so async we have to do some more changes. But yes, LangGraph provides us an option to run things asynchronously. Okay, I hope that helps, Sudarshan. Great. Cool. Thank you, everyone. Have a great time. Thank you,
Yeah.
Malvika.
Thank you. Thank you
Bye,
all.
guys.
That was a great session.
Thank you, sir.
Thanks.